Good morning, this is Mr. Herman. This video is about solving exponential equations with different bases. Our first method. We're going to learn a second method in a following video that we will also discuss on Friday. But you should have just watched a video that is talking about solving exponential equations with the same base. Okay, so we're going to draw upon that a little bit, but the first part is going to be a little bit different. Okay, we'll start off with a couple examples, then we'll go in sort of a step-by-step method of how we can solve these problems, as well as a few important tips and patterns to look for. Okay, so let's start off with a problem that is, let's say, 8 raised to the x plus 1 equals 2 raised to the 5x minus 3. Okay, now as we notice here, last time we had the same base here. However, here we've got 8 and we've got 2. But I'm going to make a special note off to the side about 2 and about 8. Okay? So there's something that these two numbers have in common. If I take 8, I want to write it with a base of 2. Okay? So I have to think of some sort of exponent. That's a bit hard to see. Let's see if I can clear that up first. Try using a different color. I'll use the sharp one. There we go. 8 equals 2 raised to the question mark. We need an exponent here. Okay? So we have to think about is 2 raised to the first. That's going to be 2. Okay, so 2 raised to the first equals 2. 2 squared equals 4. 2 raised to the third equals 8. Okay? So that is then the relationship that we want to use here. Okay? So what we're trying to do is we're trying to rewrite the base so that they're the same. So now what we have is we have 2 raised to the third raised to the x plus 1 equals 2 raised to the 5x minus 3. Alright? So now we have a little issue here. This isn't completely simplified. We have to use our raise a power to a power property. Okay, so we looked at these a few weeks ago, and that tells us that we have to multiply this exponent times this entire exponent up here. Okay, so our new expression will be 2 raised to the 3x, distribute there, plus 3, distribute over here. Okay, and then we can say that equals just the same thing, 2 raised to the 5x minus 3. Now this gets us to a place where we have the same base. Okay, and we just looked at a video where we were solving these problems with the same base. So that means we want to take our two equations, take those exponents, and set them equal to each other. Alright? So now let's go ahead and solve this equation here. Once again, just a little classic two-step. You can add 3 to both sides. So you have 5x on the right, 3x plus 6 on the left. Subtract 3x over here, subtract 3x over here. So 6 equals 2x. Divide by 2, we get x equals 3. Alright, so now let's go ahead and check. Okay, I want to plug into the original equation so you can make sure that we've got two equivalent expressions. Okay, so we had 8 raised to the 3 plus 1, 2 raised to the 5 times 3 minus 3. So that gives us 8 raised to the 4th power is equal to 2 raised to the 15 minus 3, the 12th power. Okay, and I'll go ahead and get my calculator out. Okay, we don't need to have all those memorized. Okay, so we've got 8 raised to the 4th is 4,096, and we've got 2 raised to the 12th equals 4,096. Okay, and so that checks out. So we worked this one out correctly. The only difference from the video before is that we looked at our bases originally, and we saw they're not the same, and we had to rewrite them so that they had the same base of 2 in this case. Okay? Usually there will be one number that you want to use as your base for both sides of your equation. Alright? We'll go ahead and do another one with a different base. Okay, we'll use a base of, let's use a base of 3 this time. So we'll say 3 raised to the 2x minus 1 equals, say, 9 raised to the 3x plus 5. Okay? Now, we notice these bases are not the same. Okay, we've got 3 and we've got 9. So take a look at our 3 is smaller. So let's try to write 9 with a base of 3. Okay, so we need 9 to equal 3 raised to the question mark base. So 3 raised to the first is 3. 3 squared is 9. Look at that. We found it right there. Okay, so we'll take what we have here on the left side. That's going to stay the same. Didn't change that base. We'll rewrite our base here. So 3 squared raised to the 3x plus 5. And then we will go ahead and distribute. Okay, we're going to distribute using our raising a power to a power. Raise a power to a power. So our left side isn't going to change at all. We're just going to bring that side down. Equals, you have to multiply that 2 by everything in our other exponents. We have 6x plus 10. Okay? So now we've got the same base. Go ahead and underline those. And we've got the same base now. So we are good to go. Those exponents have got to be the same. So we've got 2x minus 1 equals 6x plus 10. Once again, we're working with the classic 2-step. That's all we're doing today, just 2 steps once we get those exponents the same. Okay, so we've got 6x on the right side, 2x minus 11 on the left side. Subtract 2x from both sides. 4x equals negative 11. Okay, we'll go ahead and divide by 4 on both sides. You get that x by itself. And you could use this, you could find a decimal here. As a fraction, it's just going to be negative 11 over 4. If you want the decimal, it's going to be negative 2.75. Okay, either of those is fine, whichever you prefer. Okay, so let's go ahead and take a look at plugging it back in. Okay, we want to check our answer. You don't have to do this all the time. I'm just showing it to you now. So you've got 3 raised to the 2. I'll use a decimal for this. Okay, so there's our left side. I'll write our room over here. 3 times negative 2.75 plus 5. Okay, notice how I put parentheses in here. It's especially important when we have a negative. Okay, so I look to have those parentheses there so we are recognizing that it's being multiplied by the entire number and including that negative there. Okay, so we've got 3 raised to the 2 times negative 2.75 minus 1. That's going to give us a real small number. 7.92 times 10 to the negative 4th equals, we'll do 9 raised to the 3 times negative 2.75 plus 5, which also gives us 7.92 times 10 to the negative 4th. Okay, so the fact that these numbers are so small, that's okay. All we need to worry about is these exponents being equivalent. Okay, so once we get our bases the same, which we did right here, okay, then we can set our exponents equal to each other and then solve for our variable. All right, so that's checked out. Let's go ahead and make a step-by-step list. You might want to write this down in your notes somewhere. We will be reviewing this on Friday, but we won't necessarily be going over in notes. We'll just want to see how we're doing. So when the bases are different, step 1, write the bases the same. Okay, so that might be too obvious, so we're going to say what that means. We want to take the bigger base and write it as the smaller base with an exponent. Now, I'm going to give you a few tips here. These are not things that you have to memorize, but they will definitely be helpful when you're writing your bases. Okay, so we have 2 to the, we'll start with 2 to the 1 equals 2, 2 squared equals 4, 2 cubed equals 8, 2 to the 4th equals 16, 2 to the 5th is 32, and 2 raised to the 6th equals 64. We might see some numbers that are bigger than that, but those are mostly the bases that we'll see of 2. We'll see 3 to the 1st is 3, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. Okay, that's pretty much everything that we'll see with base 3. And then we'll see base 5, 5 to the 1st is 5, 5 squared equals 25, 5 raised to the 3rd power is 125. So you might see numbers that are bigger than these. These are the common numbers that you will see. Okay, so these, you don't need to memorize them necessarily, but if you do have a good idea of these numbers, you can tell, okay, I have a base of 2, base of 3, base of 5, then try to figure out what your exponent is. All right, so we'll go ahead and finish up our steps here. So once we've got the bases the same, we want to raise a power to a power so that each side, okay, that'll get that more in the light, each side has one exponent. And then our last part, set exponents equal to each other, and solve for the variable. Okay, hopefully you found this video helpful. You will go ahead and work on the assignment on blend space. If you need any refresher, you can come back to this video. We will be discussing this on Friday in class. We are going to look at one more method of solving exponential equations that will work on these types of equations in the next video. All right? Thanks.